So in this video we're going to be looking at the way in which data is stored within files. So this covers various different parts of the syllabus which are looking at files. You'll find these in your syllabus if you go and look that up online. But we'll start off by talking about the different types of file organisation, and we can simply, rather than just putting data in files, which is serial organisation, we can organise it sequentially using index sequential organisation, or we can do random or direct access to the file, and we're going to cover each of these topics. First of all, serial files. These are the simplest. The data is simply stored in name. There's no particular order. So it's not ordered, it's usually just added to the file by chronological order. So the ordering of the data depends on the time when the record was stored. Beyond that, there is no order to the data in the file. So these are what this means. If we're going to find a record within the file, we need to start at the beginning and then search for each record in turn until we find the one we want. And that makes searching very slow. If you imagine you've got 1 million records and you want to find one particular record, that would take a long time to do, or could take a long time to do. So we only therefore use this with small amounts of data, or when we have a file which contains records of which we're going to process all of the ones at once. And that's, for example, if you're going to process a batch of data in one go. Now, if you refer back to the master and transaction files idea from the Introduction to Files presentation, you might remember that a transaction file holds the changes that are made to the master file. So transaction files are ideal files for storing in a serial format. When people add money or take money from a bank account, it doesn't really matter. We need the records, all of the records, so that we can then go and update the master file, so you can simply add them to the transaction file. And similarly, if you imagine someone walking around a housing estate reading electricity meters, they'll simply visit houses probably in some kind of rough order, but they won't necessarily be able to visit the houses in number order, because they might have people coming and going, some of the people might be out and so on. So the meter reader will simply visit a house, read the meter reading, write it down in their transaction file, visit the next house, whichever one that happens to be. So there's no particular order to the meter readings in there. So when you process those, you're going to have to do something clever with those, which is what we covered in the last presentation. But anyway, moving onwards. If we're going to add data to a serial file, we always append it to the very end of the file, so it's quite easy to do. And if we want to delete data, though, it's a little bit more difficult, because what we need to do is create a new file and then copy records across from the old file to the new one, except for the one or the ones that you want to delete. So as an algorithm, the way you write that would be you create your new file, and then you go into a loop, probably a while loop, while not end of file loop. Read the next record in the file. So when you've just opened the file, that will get the first record. If the record is not being deleted, you copy it across the new file. Otherwise, you do nothing with that record, just leave it alone. And then you finish your loop, and once you've done that, you then rename your files. So you change the current file becomes the old file, the new file becomes the current file, and at that point you've got a new file with the relevant records removed from it. Now, with serial files, they give very slow search times. So on average, you're going to be looking at the number of reads you're going to have to do is the equivalent to the number of records in the file divided by 2. So for small numbers, that's fine, but for large number of records in files, that's something you probably want to avoid. Advantages: they're pretty easy to program because they use very simple read and write mechanisms. They are very good when you need to process all the records in the file, because that has no impact on the efficiency of the process, because you're going to be processing everything. They need the least amount of storage of all the file organisations that we're going to talk about, because there are very few overheads in running one of these files, and they're very easy to add new records because we just plop them on the end of the file. Now, if you are doing something a little bit different though, you might want to go for a sequentially organised file. So in a sequentially organised file, the data is organised in some kind of order, some kind of key, for example, first name or account number or something like that. So we often use these when we want to process all the data in batch. So going back to our master and transaction files, the master file would usually be stored in sequential format. So that means the data's got to be sorted. And an example of this would be producing any kind of bill or producing a payroll. So if we want to add a record to one of these files, the process is that we copy all the records across to a new file until the position of the record we're going to insert. We then add the new record to the new file, and then we copy the rest of the contents of the file over. And if we need to add multiple records, what we want to do is get all the updates. We sort those first of all, and then we perform this process of start at the beginning of the file, copy a record across until you get to the position of one of your next one to add. You can then add that, and then you can copy over the next ones until you find the next one to add, and so on. If you want to delete a record, then again what we do is we copy the records from the old file into a new file until you find the one you want to delete. You don't copy that one over, but then you copy over all the remaining records in the file. And again, once you've done that, again, you're going to have to do some file renaming. But the key thing here is, again, if you're doing multiple deletions, you need to take those the record numbers you're deleting, sort those, get them in sorted order, and then once you've done that, you can head off and actually start deleting data from the main file. Now, with sequential files, what we're saying is that they are relatively easy to program because they use simple searches. They're very fast and efficient because you're going to process all the data in one go. Fairly low storage requirements, but the downside are that they are, if you want to find an individual record, it's relatively slow to find it, and it's relatively complicated to add a new record to the file. You've got to do quite a complicated piece of programming to do that. We have a third kind of file called an index sequential file. Now you can consider these two files as having two parts. There's the part of the file that contains the data, and then there's an index, and the index works in the same way that an index does in a book. So far we talked about serial files, which really have no order, sequential files, which are sorted, and then index sequential, which is a sorted file with some kind of index. So the records are sorted in key order, and we use an index structure to allow us to get direct access to the data. And what that means is we can use the index to find an individual record. So the index works just like a book index, and it holds a record number, and it doesn't hold any data there. So the index is sorted, and it indicates where the files are. The data portion is not sorted. So you can kind of think of, if you think about, say, an index in a book, you've got the keywords there, and then there's reference to which pages you find those on. The pages that you refer to could be any order in the book, though. So the index is clearly sorted, the data portion of the file is not sorted. So we then have, this allows us to do either sequential access, in which case we just go straight to the data portion of the file and read through the records one by one, or we can do direct access to the file, in which case we read the index, find the record number we want, and then reopen it and get to it directly. So we can, with these kind of files, you can process them both in batch and you can process them individually. And if you just think back on the serial and sequential files, we were saying that we can only process those if we're processing all the records in the file, really, which is batch processing. So these are actually a good hybrid. So in batch processing, you process all the records in the batch in one go. The kind of processing you tend to do tends to be very, very repetitive. So you just do the same. You're performing essentially the same process over and over again, but with a different record each time. And for that reason, we usually do this kind of processing off-peak, which basically means when the computer isn't heavily being used. So typically in the middle of the night. And this kind of stuff tends to happen with no or little, if any, human intervention. The human might need to start the process running, and that's it. And in fact, a lot of batch processing just automatically happens. Scheduler starts it off and it just gets on with it. So examples of that would be producing bills. We often do this in the middle of the night when the computer's not really being used much. But equally, in an index sequential, you can do your batch processing to produce your bills overnight, and then when the customers phone up during the day and you need to look up individual records one by one, you can use the index on part of the file to do that, to allow you to do your direct access. Now, indexes can have multiple levels. So this is a picture here which is trying to show you how they work. So at the top you've got a little table, and you'll notice that it has numbers in it, 5, 110 and so on. So the idea is this 5 here refers to the first value in the first table underneath this level. 110 refers to the first table in the next level over here, and so on. So let's imagine that we had a third table over here which started off with number 300. We would then put the number 300 in as the third entry in this first table. If we then look at this first subtable here, which is level 2, you notice the first entry says 5, so that tells us the first entry in this first record over here is 5. The next one says 15, so that tells us the next level starts with 50, or the next table starts with 15. This 30 refers to this one, 72 refers to this one, and then over here the 110, that refers to the next table across. So you can see that these simply refer to the first table in the relevant entry. So when you want to search, you simply look at this table here, and let's say we want to search for number 16. We know 16 comes after 5 but before 110, so we know we need this table over here. We then know we want 16, so it's not the first table, it's not the second one, it's got to be the third one because that's the next value is 30, so we want this table over here. It comes after the 15 but before this 30, so it's over here, and we can find the 16 we want right here. So we have a third leaf down here which contains, this one could contain the record numbers for the individual records we need to go and look at, or it could actually point to another level in the file. Now I'm sure you can imagine because what you're doing is you're going from one table to another, and then eventually finding the data you want. I'm sure you can imagine that the more levels you have in these indexes, the less efficient the searching mechanisms become. Now, one disadvantage of index sequential files is that the index takes up extra storage space, so the amount of space the file will take up is required, and every time you want to put a new value into the file, you're going to have to insert that entry into the index, which means you're going to have to sort the index and maintain that. So there's an overhead in doing that. So saving data into these files is slightly slower, but you get faster access to your records. You can either access them, if you're looking for an individual record, you're going to get significantly faster access to one record. If you imagine you've got 1 million records, then the number of lookups you're going to have to do is going to be something of the order of the square root of 1 million minus 1. That's because the index significantly narrows down the part of the file that you need to look through and search through record by record, because it takes you almost pretty much directly to the record you want, and that makes it very efficient for searching for individual records, but you can also efficiently read through all the data in one go. So if you've got a file which has mixed use, index sequential is a good way of organising your data. Now we're going to talk about random access files, sometimes called direct access files. These are used in conjunction with these things called hashing algorithms. So with a hashing algorithm, what we do is we take a piece of data, so typically a key value, like for example someone's name or maybe an account number. We then pass it to a thing called this hashing algorithm. And what will happen is the hashing algorithm will then do some kind of mathematical calculation, and it will send back a number which is the physical location that the record is found in the file. And this gives us very, very fast access to our data. So we use this when we want very quick access to single individual records, but not when we want to process all the data in the file in one go. That'd be a bad use of direct access files. So examples of this might be a patient system for, say, a doctor. So when the doctor wants to look up a patient, they can just type their name in and find the record straight away. Or maybe when you want to book a ticket for the cinema, because in that case you're going to look up one entry and come back with one record. So here's an example of how one might work. So what we're going to do is we're going to have a unique record ID number. Let's say it's the account number for a person. And what we're going to do is we're going to take that record number and then divide it by a prime number which is close to the number of records in the file. That'll give us a remainder, and the remainder is going to be the storage location. Now you might be thinking, well, what happens if I type in a person's name? How's it going to do maths on a name? Well, we've got to remember that everything is stored in numerical format in the computer, in binary format. So what we can do is we can take the text of the name, for example. We could then take the ASCII codes for the letters within the person's name. We could add them up and that would produce a number, and we could use that as our first number there. But notice this significant value, we need a prime number which is close to the number of records in the file. Now here's an example. So let's imagine we've got 10,000 records in our file and we have 8-digit record numbers. So we've got this number here, 2345238676. Well, if we look for take 10,000, the nearest prime to that is 9997. So what we can do now is we do the record ID, which is this number that starts 234. We then use the mod function. If you remember, modulus is the mathematical function that divides two numbers together and gives us the remainder. So we mod the record ID with the prime that we've produced, and that gives us 905. So that tells us that we are going to store this record in location 905. So when you want to store the record, you simply use the hashing algorithm to work out where to put the record. When you want to find it, use the hashing algorithm to work out where to find the record. Now the problem with this is it can generate these things called data collisions. So a data collision is where the hashing algorithm generates the same location for multiple records. So if we give it, say, one of 5 keys, in every situation it will generate exactly the same key storage location, and clearly we can only have one piece in each location, so that gives us a bit of a problem. And when that happens, we get a thing called a data collision. Now what we can deal with this in really 2 different ways. One is which we can save the data into an overflow area, and the other one is which we can use these things called buckets. So we'll talk about overflows in a moment, but with buckets what will happen is the hash will tell us, you can imagine your file is divided up into these containers called buckets. So imagine you've got a row of buckets side by side, and what will happen is when we do the hash, it simply tells us which buckets are referred to. So bucket number 1, bucket number 2, bucket number 3. And what we then do is we know which bucket to put the data in, so we can simply take our piece of data, we go to the bucket, and we simply start at the beginning, and then we serially read through the bucket until we find a space, and then we put the piece of data in that space. So if you imagine I gave you 10 buckets, and then I gave you a list of 1,000 things and simply said put them in the buckets according to this set of rules. The rules I've given you are the hash, and you can simply then just stick the things in the buckets, and obviously this is great until the bucket completely fills up. Now if we refer to these buckets though, the problem is they can eventually fill up, and the other method that we referred to, if we go back a moment, is this use of an overflow area. So the idea here is we perform the hash, it calculates an address, we go to that address and it's in use. So in that case what we'll simply do is we'll have a designated overflow area, and we simply take the record and we pop it in the end of the overflow area. Now clearly what's going to happen with these is if the file's becoming very, very full, then you're going to get lots of overflows, or the buckets are going to get over full, and that's going to slow down your access, because then everything's going to end up in the overflow area, and when you get to the overflow area, searching is quite difficult. What this means is every now and then we need to reorganize the files. And when we reorganize the data, it kind of gets redistributed, and everything access becomes quite good. So you will need to do this when the overflow area is becoming too big or the buckets are becoming too full. And the problem with doing this though is that when you reorganize the file, you'll need to come up with a new hashing algorithm, because you will have a larger file as a result of this, and therefore we need to use a different prime number in our calculations. Now when it comes to searching, what we do is we take the key value, we pass it to the hashing algorithm, and that gives us a storage location. Then if we're using the overflow method, we'll read the storage location. If it doesn't contain a record, we'll pop our data in there. That's the data we want. Otherwise we'll go to the overflow area and we simply serially search through the overflow area until we find the record we want. If we're using the buckets system, what will happen is we will use the key to identify which bucket we're going to use, and then once we've got to the bucket, we search for it sequentially until we find the file. If we're going to add records, what we're going to do is we're going to pass the key to the hashing algorithm to find the location of the storage the bucket that we need. We're going to go to that bucket. If there's space, we'll put it in there, and if there isn't space, we'll add it to the end of the area. And if we want to delete data, the approach is that we use the hashing algorithm to identify the storage location. We then go there, we delete the record, and if the record we want isn't there, we then go to the overflow area and we read through that. And you'll notice I've said that we mark the record, because often we don't actually physically remove data, we just simply say this has been deleted. So next time you go to save something, it will see that and it will say, okay, I can overwrite that, and that speeds up access to data. Now, the advantage of direct access or the random access files is it's the quickest method to find individual records. It works very, very well with large files, and you can very easily add new records if you've set your systems up properly, but it takes up a lot more storage space, and this is because you're going to waste space for allowing gaps for adding your new records, and you'll typically use at least twice the space of an equivalent sequential file. It's also very inefficient for batch processing, because the system will read the first record, then the second one, the third one. It will read the start of the file, the end of the file, the middle of the file, the end of the file, the start of the file, and rather than just reading through the records one by one. And that you will need to reorganize your data periodically, because when overflow areas start to become too large, and you're going to end up with a file which is going to contain a lot of empty space, because you need gaps to put your new data into, so it doesn't make the best use of disk storage space.